Okay, welcome tonight. We're going to work on division of rational values as our first step. Then we'll go into adding and subtracting. We've already done multiplication. A little bit of review. When you have division, you have one additional step that you don't have in addition. In multiplication. That one additional step you have is you have to take the reciprocal of the divisor, and all of this behind the divide sign is the divisor. Now, you can either take the reciprocal first and then factor every term, or you can factor every term and take the reciprocal. Either way, you have to do both before you can do any canceling. And the fact that you have to do both is important. Okay. Well, this one I get to work up here. Let's go ahead and flip it first. X squared plus x over 5x cubed minus x squared. Uh-oh, I got a negative x in there. Times 25x squared minus 1 over 10x squared plus 12x plus 2. Now, in some ways, it's better to go ahead and flip it first so you don't get busy and forget. Okay? Just as a suggestion. So now we need to factor everything. Well, let's see. I can factor an x out of this. So I've got x times x plus 1. I can factor an x squared out of this. So I've got 5x minus 1. Okay. This is a conjugate pair, perfect square on the front, perfect square on the back, minus in the middle. So this is 5x minus 1, 5x plus 1. And this one, I don't know if I can factor it or not.
10x plus 2 and then x plus 1.
Okay. Well, it's got the right potential numbers in it, and everything is pluses. Well, let's see. 10 times x is 10x squared. 2 times 1 is 2. Here I've got 2x, and here I've got 10x. That makes 12x, so yes, you're right. Okay. Thank you. All right, now that we got this thing factored, now we can cancel. Well, do I have anything that will cancel? Any top with any bottom is the rule. This one will cancel with that one. Okay. 5x minus 1, 5x minus 1. Okay. Let's see if I have anything else. Nothing up there that'll cancel with this one. Nothing up there. Bing. X once, x squared, x times. You see what I'm doing there? Easy to miss that one, wasn't it? Okay, so now we're going to multiply out whatever's left. So I've got 1 times 1 times 1 times 5x plus 1 all over x times 10x plus 2. And you can leave the answer like that. You don't have to multiply that out. Okay. especially if it says factor completely. Any questions on this one? Any uncertainties? Want to know what I did, why I did, how I did? Yes.
Even though there's an extra, you can still take the next side. You can hold one on the top.
Leaves you 1 over x.
Oh, okay.
It's easier to see if it were x squared on top, but it'll work either way. Yes. Louder.
10x plus 2, can you take out like 2?
Actually, I could. Thank you. I can take a 2 out of this and further factor it into 5x plus 1. That changes my whole problem. Let's get rid of this stuff. Thank you so much. Does it make you feel better to know that sometimes even the instructor misses stuff like that too? That will cancel with this. So I now have 1 times 1 times 1 times 1, which is 1, over x times 2, or simply 2x. Good catch. That way I know you're paying attention. Question? Okay. All right, well, if there are no more questions on this one, I'll erase these scribbles and then we'll continue. But again, it's kind of a pretty routine process, isn't it? Which brings up the next step. The difference here is we got to play the common denominator game. Just like we did before. Now, I've given you an introduction to this already, where we had to find the LCD before, okay? And just like then, writing down the LCD equals is worth 1 point partial by itself, okay? Just like before. Now, don't worry about this gibberish right here. What this is saying is if you got this fraction and that fraction, they get the same denominator, you can common denominatoralize them. My made up word. Okay, that's all that says. Likewise, if you're subtracting them, if you have the same denominator, you can put them under a common denominator. Back to 5th grade arithmetic. We've got a common denominator. What they're wanting us to show is you can put it under a common one, get that, and of course, if you can reduce it, you must. Okay. Now we get a little more complicated, but we still have a common denominator. So in this case, we've got this 5x here and that 3 there that we can add together over the common denominator of 2x minus 1. And that happens to be as far as we can take that particular one. Again, we have a common denominator. So we can take this and combine it with those two, all over x minus 4. Now, we don't really need that for parentheses, except we've got to, when we deal with it, we've got to change the sign of both of these, like so. Now then, what do you suppose we got to do next? Factor. Factor. Okay, what kind of signs are we going to have? One's a plus, one's a minus. Sign of the biggest is going to be minus. Okay, so that thing factors into this. And we got that. We got something we can cancel. We're kind of getting back to the pattern we had before now, because now everything is multiplication and division. We've gotten rid of all the pluses and minuses of groups. Okay, so that they cancel, and the answer is just simply x plus 3.
So would you take points off the group of x plus 3 over 1?
Is that the simplest form? Okay, you answered your question. I'm really not trying to be a smart aleck. Okay, now, what's the answer here?
They were using 1 over 1.
5 minus 1 is 4. 4/12 reduces to 1/3. Somebody said that a moment ago. Okay, we got a common denominator here. The 3 and the 8 are going to combine to make a positive 5. So 4c plus 5 over c minus 2. This one, we got to combine those over t minus 7. It gets a look, and then factor that. And that is a minus and a plus. So, that'll be a minus when you distribute this minus in the middle. So you'll have a plus 1 and a minus. So you're going to have t minus 7 and t plus 5, or t plus 2. 7 minus 2 gives you 5. And so the t minus 7s will cancel. Least common denominator. You can read that. You see how long I left it on it. Factor all denominators completely. Least common denominator is the product of all the prime terms. Okay? Here, those 3 numbers share some parts. In fact, 3 will go into all of them. 6 will go into all of them. Okay? But that's not what least common denominator is. That's greatest common factor. The least common denominator is the smallest number that all 3 of these will go into. Now, how do we get that? If you break down the 12, it's 2 to the second 4 times 3 to the hidden first. Those commas are just separating these 3 terms. The 18 is 2 to the first, and I would recommend putting these firsts down. I'll get the lid off of this silly pen. Okay. Now, and then the 30 is that. Now, here is the trick. Those are all prime numbers, right? Prime numbers are numbers that only one in itself will go into. What you do is you take the highest power of each individual prime number. The highest power of each prime number. If I consider 2s, the highest power of 2s that I've got is 2 to the second. The highest power of 3s that I've got is 3 to the second. And the highest power of 5s I've got is 5 to the first. Okay. Now, if you wanted to, you could change this into 4 and 9 and 5. Okay. Multiply those together. 4 times 5 is 20, times 9 is 180. That's the least common denominator. Okay. And then we have to deal with it. These aren't pluses, so all they're wanting us to do is do that. Now, that's all that they ask us to do. They didn't ask us to rename the numerators. That would ordinarily be the next step. But we don't have to on this particular problem. Any questions about how I got this 180? Okay. There is another way of doing it. It's called list of multiples. I don't recommend this one. Okay, to the second power, or times 2 rather, you would have 24, you would have 36, and you would have 60. Times 3, you would have 36, 72, no, 54, and 90. Well, I got a 2-way match here, but I don't have a 3-way. Because there's 3 numbers, I gotta have a 3-way match. Well, times 4, I would have a, 48? Now I would have 72. And here I would have 120. So times 5, then I would have what?
60.
Yeah, 60. I'm brain dead right now. Okay, and this one would be 80, 90. Okay, there's a 2-way match, but still no prize. And this one gives us 150. Times 6. Okay, here you've got 72. There's a 2-way match. Here you've got 108. No help there. And here you have 180. Times 7. You get the idea? I don't want to finish this thing because I got to go way out there before I get a 180 on all 3 of these. Because I'm only about halfway to 180 here, less than halfway. So I'm going to be way out here to maybe like times 12 or 15 or something. Okay, actually it will be 15. And so this is, I mean, that's a way you can do it, but it's not necessarily a way I recommend. Well, we'll go on with theirs. Here you can see they chose the highest power of each prime number. Just like I did, except I illustrated it a little bit more. Now, what about this one? Well, 2 goes into 16. So 16 is going to be the numerical part of it. Now let's consider x's. What's the highest power of x's? X cubed. What's the highest power of y's? Y squared. And what's the highest power of z's? Z to the first. So this is your least common denominator.
Why would it not be 2?
Because if you consider 2, which is 2 to the first, and you consider 16, which is 2 to the fourth, 2 times 2 is 4, times 2 is 8, times 2 is 16. Then your highest power of prime number 2 is 2 to the fourth, which is 16. Okay, so we've pretty much answered that question. Okay, this one. Okay, here you got, here are the multiples of that. Here are the multiples of that. Here are the multiples of this. Okay, the highest power business. 8 is 2 to the third. Right? So anyway, you get 240. What about this one? 9 goes into 18, so it's going to be 18. Okay, now, A to the fourth is the highest power, B to the second is the highest power. What about this thing? Well, we got to factor these first. Okay, we've got to factor these. So this factors into plus 5 and 4 makes 9. This factors into that. So what is my common denominator? It's x plus 4 times x plus 4 times x plus 5 is the LCD. Now, this could be written this way. Like that. And now you can see that it fits my highest power rule. These two together are x plus 4 to the second. Okay. This one is just x plus 5 to the first. This is included in that. Okay. Yes. Yes. Thank you, though. Thank you, though. Okay, so this is my least common denominator on that. That's all it's asking us to do so far. I think you're going to get to see this one with their solution as I run through it. They factored it. Now, see, they showed it that way. And there it is, same as I had. Okay, what about this one? Well, this one, we got to do this. Now, you understand what I did here out of that thing? 3 minus x. If I take a negative out of both of those, then if I take a -1 out of both of these, then that one becomes -3. This one becomes positive x. Then all I did was switch the order up. Okay. We did some of these where you had the opposite order with the negatives before, getting that negative out, factoring that negative out of there. Well, you run into that in these things too. And they're kind of a pain. Now, you could put, what is your, I haven't finished this problem. What is the least common denominator? Well, this is just the same thing on both of these, and both of these are to the first power. So my least common denominator then is -1 times x minus 3. Okay. It's not in here again tonight, or maybe it's just because I'm wearing this long sleeve shirt. Okay, see here, this is talking about when I was saying these are opposite factors. So you got to take a -1 out of one of them. And they did it, and so, yeah. Okay, now, these. Got to factor this, got to factor that. Well, let's see. This one is x plus 2 squared. X plus 2 times x plus 2. And this one is one's a plus, one's a minus. Yeah, we're going to have 3 and 2. Sign of the biggest is the 3. So the 3 has to be there, the 2 has to be there. Now we look at these terms. This one, remember, is a first power. That one is also a first power, parentheses. Okay. And what is my rule? Take the highest power of each term. Well, here's the highest power of this one. And that one's included in one of these. So then x minus 3. That would be it. Now, later on, when we actually start working with problems, you probably won't show it that way. You may write LCD equals that, but when you're actually working the problem, you're probably going to do this. Okay. When we start distributing the least common denominator to every term. Okay, that one, we got opposite set there again. These two are just opposite signs of each other. So I like this one. That one is the one I'm going to modify and make it -1 times -7 plus z, which in turn becomes, and I better put a parentheses around there so I don't think that's a subtraction. And then I'm going to switch the order of these. So both of these are the first power. So I just list it once, z minus 7, and then I've got to list that. So here's my LCD. Oh, this might help a little. Is that one off too? Yes, definitely, please. Any questions on either of these two? So what's the general rule? Take the highest power of each terms. Equivalent rational expressions. Let's go back to the weird number. Remember that little video I showed you the very first night? What was the most famous statement that 763 the sheriff said while 2/3 was in the barn hiding? If we can take different forms, then they can too. This is all about just the same value, the same worth, but just in different form. The cheapest example of this is 10 dimes and $1 or 100 pennies are all the same value, but they are in different form. Likewise, fractions can have different forms like 4/6 and so on from the movie, okay? Well, that's what we're talking about here. Now, all we're doing in this is we got this fraction and we want to put it in a different form with this as the denominator. Why would we want to do that? Maybe this is the least common denominator. Okay? So what we do is we look at what is in this one that goes into that one and what is missing in this one that is in that one, which is more important. Okay? So what is missing in this one that is in that one? Well, a 4. Okay? A 4 is missing in that one compared to that one. So if I took times 4 there and times 4 here. What else is missing? P to the 4th. Okay? So then I would also multiply by P to the 4th and P to the 4th. So I multiply them both. Well, this stuff times that gives me that. This times that gives me 28 P to the 4th. This has equivalent value to that. Okay? So that's what we're talking about on this basis. Basically, here they're showing it. I multiplied by 4 over 4 this way. They got more formal with it. Made it prettier. But same result. Now let's see what we got here. We're getting a little more complicated. Okay. Well, on these, I've got a W plus 5 to the first there, right? If I factor this, I get a one's a plus, one's a minus, 5 and 2, subtract to get 3, and the 5 has to be the plus because of that. Oops, 2, not 3. Okay, so that factors into that. What is this fraction missing that that fraction has? Well, it's missing the x minus 2. Well, okay. All of these are supposed to be W's. My bad. Are you happy? Well, there they go. And here's another 2 more we can do. Well, did I make a mistake somewhere? Apparently, I had some stuff I could have canceled out. Yeah, I multiplied everything by the whole thing, not just the missing part. I screwed up. I multiplied it by the whole thing, the common denominator, not just the missing part. Top and bottom. So that's what I did wrong. My bad. And so far tonight's not being a very good night for me. Ready to go home, are you? Well, believe it or not, I am too. I think I've fried my brain grading all your tests.
Maybe that's what happened.
Do what? This one? Here was the missing part. We had this broke down into W plus 5, W minus 2. So the missing part was just this. And you have to multiply missing part top and bottom. Oops, I'm going the wrong way. Okay, addition and subtraction of those with unlike denominators. Well, actually, we've already been doing that some. Okay, so here are the steps. Okay, find the LCD. We've done that. Write them as equivalent expressions with the LCD as its denominator. Now, this is a little bit different than that last problem. Okay, we're not going to deal with missing parts. If it is an, oh, it says expression, so yes, we will have to deal with missing parts. Okay. If it says equation, then we deal with LCD in total. For expressions, we have to deal with missing parts. Okay, so what are we missing? We're missing a 7 out of this one, and we're missing a second B out of this one, aren't we? So what are we going to do? We're going to multiply this one times B over B. And this one we're going to multiply times 7 over 7. Okay. So I get 3 times 6 is 18 over 7b squared plus 28 over 7b squared, which gives me 7b squared as the common denominator. Yeah, you don't have to show this step I'm showing right now. You can go straight to this step. Okay, 18 plus 28 is what, 46 over 7b squared.
Where did you get the 18 from?
3 times 6. Oh, that's a b. Duh. 3b. 3b. That's no longer 46. That's just 3b plus 28. That's as far as you can go on this one. The only thing more you could do is if you could factor a 7 out of both of these and cancel it, but in this one you can't. Something you cannot do. Put your head up, please. Thank you. It offends me if you sleep in my class. Something you cannot do is you cannot divide this 7 into that and not also divide it into this. And that's a very common error that students will make. Okay, here's just another one we're going to go on. Subtract. Okay, now we got to deal with a minus in the middle. So ideally, you would want to change this to plus -5. Would be the easiest way to deal with that. They chose not to. They decided to go ahead and factor the denominators first. Okay. Now, they looked at what's missing. This one is missing a times 2. That one is missing a times t minus 2. So here's the 2 over 2. Here's the t minus 2 over t minus 2. Okay, and you've got this minus that over common denominator of 2 times t plus 6 t minus 2. Now we've got to distribute this, distribute that, so we can combine like terms. This just left off, this is where it left off in the previous. That was the bottom step of the previous. So I distribute this 2 and I get this. I distribute that -5 and I get this over the common denominator. Now I'm going to combine like terms. And combining all of that, I get t plus 6. Guess what? I cancel those 2. So I do that. And what have I got left? Again, this was the last step before. Do I still need to go back? Okay. All right. You guys still working on those 2?
Yes.
All right. No problem.
And so from the second line to the third line, where did we get the 2 plus 6 again?
16 minus 5 is 1 2. And then
I'm
positive
from
sign
here to here.
Yes.
16 minus 5t is what t? -4 plus 10 is positive 6. Over the common denominator. Now can I go on?
1 second.
Okay, here's the same step that was up there before. So we cancel the t plus 6's, and there's our answer. Good evening. Thank you. I should have another one of these. Oh, did you bring me your test? Okay, never mind. Sorry. Okay, so what about these? You feel like you need to do this one, or can we go on? Anyone want to see this one? Yes or no? Okay. Now we got adds and subtracts. They just keep getting nastier. Well, let's deal with this one. X plus 3, and this is going to factor into x times x plus 3. Okay, so between all 3 of these, I got the same stuff. So what have I got to do to this one? I got to multiply by x plus 3 and x plus 3. This one, I've got the x plus 3, but I'm missing the x. So I have to multiply this by x and this by x. That one's got everything in the denominator, so I don't have to do anything to it. So now, that stuff having been done, and they're just caught up with me. You see how I just did all of the work in that one spot instead of rewriting all that hundreds of numbers. Okay, so now we got 2 times x plus 3. Here we have an x squared. Here we have the minus group 3x plus 18. And you really have to be careful to remember to group behind that minus. And then down here we got x plus 3 on everything. Now, any questions before I go on? Okay. All right, so get this out of the way. Now I'm ready to distribute that and distribute this negative. So I get 2x plus 6 there. Here's the x squared. And I distribute this negative to both of those over that. Now I'm going to combine like terms. When I do that, I get this thing. Guess what I gotta do next?
Back to the top.
Factor the top. Okay, what does this factor into? One's a plus, one's a minus, the difference is 1. 4 and 3 has a difference of 1. The biggest one's gotta be, so the 4's gotta be the negative one. So we factor this into these two. We can cancel the x plus 3's.
So it would just be x minus 4 over x.
And we get just x minus 4 over x. Say again. Not if they're in a parentheses, you can't. Because it's got to go into, kind of like the Three Musketeers, all for one, one for all. It's got to go into all of them. Okay. Okay, well, we're going to skip that one. Now we're going to do some subtraction. The only difference in addition and subtraction is you subtract the numerators instead of add them. That's the only difference. All that business with the common denominator, all that business of what is missing, all of that is the same. The only difference is at the end you subtract instead of add. Okay? So, what are we missing in this one? A -1. So I'm going to multiply this by -1 over -1. They're showing that. So I've now got, by the way, this negative and that negative cancel each other out conveniently. That won't always work that nicely. And here we got a -4. Now we're going to common denominatorize this over a single W. 6 minus -4 is 10 over W. Okay, here's another one very similar to the last one. We're going to have to multiply that by a negative. And when it does this and that, we'll cancel off the negatives. Okay, let's go with this one. We got reversed order with minuses. So I'm going to have to factor a -1 probably out of this one. Okay, so I did. Or I'm going to multiply a -1 times both of them. Now, this times that gives me that. This times that lets me switch the order. So I now have a common denominator. So I'm going to put them both over the common denominator. So I get this minus that. Well, guess what? That's a conjugate that we can factor. Perfect square on the front, perfect square on the back, minus in the middle. And when we factor this, the x minus y's will cancel. And we got just simply x plus y. Well, there's someone wanting this. Okay. Just like before, when we had this plus that, we could change it to this. You can go the other way too. You can go either way. You can either common denominatorialize it, or you can get this, uncommon denominatorialize it. Okay? Play on words, of course, and then this one's a minus instead of a plus. So what about this then? You remember with the parentheses a couple of minutes ago, we said it was all for one, one for all. I've got to be, before I can divide anything out of these with that, it's got to go into all of them. Now, in this case, it actually does. In this case, 3x will go into 3x fourth x squared times. The 3 is gone. Oh, no, wrong, x to the third. Okay? Because I'm just dividing out one of those 4 times x's. Okay, here, the 3 goes into 6 2 times, and the x goes into the x cubed x squared times. And this one, the 3 goes into the 9 3 times, and the x goes into the x 1 time. So what does this thing work out to be? X cubed minus 2x squared plus 3 over 1, but we don't need to show that. Now, that's one way to work this problem. Yeah. Let's look at a different way of working this same problem. 3x to the fourth over 3x minus 6x cubed over 3x plus 9x over 3x. This time I uncommon denominatorialized. Well, once again, I cancel whatever I can. The 3's cancel. This x cancels out one of those, leaving x cubed. Here, the 3 and the 6 cancel. This cancels out one of those, so I've got x squared. The 3 cancels that, and this entirely wipes out that, so I still get x cubed minus 2x squared plus 3. 2 different ways of doing it. Okay. Now, which way is best? Neither. It depends on the numbers in the problem. Okay. Now, if these hadn't have gone into one of those, we wouldn't have had a choice. We would have had to do it this way. Which way did they decide to do it? They decided to uncommon denominatorialize. What does this mean? This means that over that. Okay, just a different way of showing it. Like so. Okay, now, by the way, a fraction bar also becomes parentheses. They group things. Okay, now, will this go into everything? No. Parts of it might, but you don't really want to go there. So what we do is we uncommon denominatorialize this thing. And we get that. Okay. Now, individually, we can reduce up and down. Like -5 and 10 gives you a -2. C squared and C3, C cubed gives you C. D squared and D gives you over D. And here and here. Well, here's what it comes out to be. Any questions on how they got this from that before I go on? Because from here to here is kind of the critical step of this problem. Turning on those fans did help some. Okay, well, if there are no questions, we'll go on. And of course, there's a hidden over 1 right there. Notice this minus got changed to a plus because of that negative down here. You got to be careful of stuff like that. And this plus got changed to minus because of that negative. That's just a couple of things to watch out for. Okay. Now, there really isn't anything more we can do with this. That's as far as we can go. Quoting my hillbilly cousins. Okay, we're going to skip these two. No, we're not going to skip these two. I will give you a choice, and I will work one of these two. Number two? Number two. Okay. You would pick the bad one. -24a cubed b squared over -8ab. You see what I'm doing? Minus 16a squared b cubed over minus 8ab plus 8ab over -8ab. Oh, okay. One time there was a conversation between two people. One of them's name was B. B-E-E or B-E-A for a name. And the first one says, "Hey, B, see the pie?" There ain't no pie. Oh, I be. A pi r squared. A, B, C, D, pi. Formula for the circumference of a circle. There ain't no pi. Them are not a pi. Oh, I missed the line. OSMR 2 pi. Radius times 2, the diameter times pi, again, the circumference. OIB, a pi r squared. Must have been a Coupler time.
What does that have to do with this?
Just AB triggered my memory of that little jingle.
I thought you were gonna go somewhere like.
But here, I tell you what, you can copy this thing down and show it to some friends and say, "Can you explain what this means?"
Oh my gosh, I thought that was.
and challenge them. Okay, well, so much for the stupidity. You gotta have a little bit of stupidity in any math class once in a while. Okay, well, here we go. Factoring. Those cancel. That goes once, this goes 4 times. Oh, that's 24. Try 3 times. That goes once, this goes a squared times. That goes once, this goes b times. Over here,
Where'd you get 4 from?
well, that was before I decided that was 24. I was gonna, when I thought this was a 2, I was gonna have a 2 and a 4. So that's a 1 there. Okay, here, these 2 cancel out. That goes once, this goes twice. That goes once, that goes a times. That goes once. That goes b squared times. This is going to make that a minus. Those 2 cancel, those 2 cancel, those 2 cancel. So I basically got -0, or -1 rather, excuse me. Okay. This part becomes -1. This part becomes 2ab squared plus in front of it. And this part becomes 3a squared b. And that's all you can do to it. Okay? Not too terribly hard, right? Okay. Your favorite topic in 5th and 6th grade, right?
Sure.
And your math teacher would load you down with 35 problems a night of long divisions. Each one took a half a page. And you despised it, right?
Yep.
But how'd you do them? Besides just guessing, that doesn't count. Did you know that there's a pattern of how you do long division? Yeah, there's a 4-step pattern. Okay, let's look at an example. 27 into 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Okay, that's far enough. Now, if I wanted to divide that, first place, I got 2 digits right here. I got 2 digits right there, but 27 won't go into 12, right? So right here has got to be the first number of my answer. So that's how I kind of figured that out. Now then, the next thing we got to do is we got to play the Gazinta game. The Gazinta game. How many times this one goes into that?
Oh.
Okay. Well, how many times does it goes into it? This is almost 30. 30, 60, 90, 120. There's your estimate, 4. See how easy it is to estimate? So, what was our first step? Estimate. Okay. Now, what are we going to do? Well, we're actually going to take this times that. Okay. 4 times 7 is 28. 4 times 2 is 8, and carry 2 makes 10. As long as this is littler than that, we can go on. So our second step was we multiply. I almost wrote division. Okay. Now, our third step is we subtract. Well, 13 minus 8 is 5. 11 minus 2 is 1, and those are wiped out. Now, my next check, red light, green light. Here I had a red light, green light. Is this littler than that? Now I got a red light, green light. Is this littler than that? And it is, so we can go on. Well, after we've done that, we do our next step. Bring down. Okay? So we bring down this 4. Almost got carried away ahead of myself. So now what we do then is we start the sequence over again. So we got to estimate how many times this is into that. Well, we're at 120 with 4. So 150 would be 5. That's still bigger. So we'll try a 5 here. Okay. 5 times 7 is 35. 5 times 2 is 10, and 3 carry. This is smaller than that, so we can go on and subtract. So 14 minus 5 is 9. 4 minus 3 is 1. We're below, so we're good. So we bring down. And we start all over again. How many 30s are in this? Now, this estimation way that I'm showing you could be off by 1. Okay. Like if it were 26, it would get off by 1 sooner than it will with 27, 28, or 29. Okay. But at least it'll get you in the ballpark, usually plus or minus 1 on your estimate. And then you got to check that. Well, you see how this works, right? Well, what we're going to be doing is we're going to be dividing polynomials. Stuff like that. But guess what? We're going to use these same 4 steps. Same 4. Let's look at this problem. Where do I want to do that? I want to do it over here so it's lit up better. So I write x minus 2, and then I write 3x squared minus 14x minus 10, and I put my division box above it. Okay? I got 2 terms here. I've got 2 terms there, so there's the first digit of my answer. Just like we did over here. Okay? Now, I gotta estimate how many times this goes into that. Right here is your estimator tool. What do you have to do to this to get that? I have to multiply this times 3x to get that, right? Okay. Now, multiplication is distribution. We got to take this 3x times the x, and we got to take 3x times the 2. So 3x times x is 3x squared. And these two better match. 3x minus times negative 2 gives me negative 6x. Now what do? I subtract. Now, when we're dealing with polynomials, remember with that lesson we had about finding the opposite? Finding the opposite and adding is the same thing as subtracting. So what we do is we take both of these and find the opposite signs. Okay? So if I do that, these two are going to cancel each other out always. Always. And this, I get whatever I got. Negative 14x and positive 6x gives me negative 8x. Okay? And now I bring down minus 10. So I have to estimate again. I go back here. What do I have to do to this to get that? Negative 8 is what I have to multiply this. So negative 8. And I distribute that negative 8. Negative 8 times x is negative 8x. Negative 8 times negative 2 is positive 16. Now, for my subtract step, I change both signs and I add. These two will cancel as usual. Negative 10 and negative 16 makes negative 26. Now, my answer on this problem then is I have 3x minus 8 plus or minus 20 remainder of negative 26. Or I could show it in fraction form, 3x minus 8 and negative 26 over x minus 2. Now, what in the hell am I talking about here? Let's go back to second grade, third grade math. 5 goes into 17. Okay, goes 3 times, 15, 2 remainder. 2 remainder. How did we give the answer in second or third grade? You said 3 remainder 2. That's what I did here. Okay. Now, what did we do in fourth grade or fifth or sixth? Same problem. We would say 3 and 2 fifths, where that is the divisor. And that's what I did here. Okay.
Is there anything that goes in between the fraction?
No.
No.
Well, I mean, I could have, it's best if you put that in a parentheses if you've got a remainder, and then plus negative 26 over that. You know, or you could use minus 26 over that. Either way would be correct. Now, do you see how dividing by polynomials is no different than dividing with whole numbers? It's the same 4-step process. And I bet probably nobody ever explained it to you that one before. So with that, go home.